All right, here's another video on determinant and inverse. So far we know that we can add and subtract matrices if they have the same number of rows and columns. In other words, if they have the same dimensions or order. We can multiply any matrix by a scalar. We can multiply matrices if the columns of the first matrix is the same as the number of rows of the second matrix. Can we divide matrices? The answer is no. However, we can find an inverse matrix which serves a similar role as division. These are inverse matrices. Here's A and here's A inverse. If you multiply inverse matrices, you get an identity matrix, all zeros with diagonals of 1. So let's see what happens if we multiply these together here. Get the pen here. A times A inverse is going to equal 4, 3, 1, 1. And then I'm multiplying by 1, -3, -1, 4. So the row times column. So 4 minus 3 in this entry right here. And then -12 plus 12. And then I have 1 minus 1. And -3 plus 4. And if I do the math, I get 1, 0, 0, 1. Sure enough, I get the identity matrix. If I multiply a matrix by its inverse, then I get the identity matrix. So in the check for understanding this week, you're going to have to find the inverse of a 2 by 2, and here's the formula. So the inverse of this matrix right here is the determinant, 1 over the determinant. So you find the determinant, and you do 1 over that, or the reciprocal of the determinant. And then you switch these two entries, D with A, and then do the opposite of C and B. So in order to find the inverse of A inverse here, then I'm going to do 1 over 6 minus 4. There's the determinant, 6 minus 4. And then I'm going to multiply. I'm going to switch these two numbers. So switch the 2 and the 3 and do the opposite of 4 and 1. So then A inverse is 1/2 the scalar, 1/2 times all these entries here. So A is going to be 1, -1/2, -2, and 3/2.
Emily, I need socks. Look at my bare feet. I need socks, Emily.
And then the inverse of B
Silly if you don't open this door.
is 1 over 14 minus 20. That's the discriminant. And then switch these two entries, the 2 and the 7, and then opposite of the other two entries. So B inverse is equal to -1/6, and then 2, -4, -5, 7, and then B inverse is -1/3,
Why aren't you opening the door for socks?
2/3,
What?
5/6,
Yeah, you don't have a good reason. That's exactly why.
and -7/6.
Emily.
All right, and let me show you on the calculator. So you can check your answer by using the calculator. So what you do is go to Desmos matrix calculator. So if I just type that in, here it is here, Desmos matrix calculator. It's this first one here, this first link. And then I want to make a new matrix here. And it's a 2x2. So when I add it, then it's asking me for the elements here. So if I go back here, it's 3, 1, 4, 2. So 3, 1, 4, 2, and then enter, and there's my matrix A. And then if I select A, well, I have to select A first before I hit the inverse. So let me delete that. So A, and then A inverse. There's the inverse, 1, -1/2, -2, and 1.5. So let me check my answer. And I got 1, -1/2, -2, and 3/2. Yep. So I have the same answer here. Let me check the other one. So we got a new matrix. It's a 2x2. Now this one's, it's naming it B since I already have it in matrix A. Or I can clear that one all out and go back to matrix A. But so just let me use matrix B as 7, 4, 5, 2. So 7, 4, 5, 2, and hit return. There's my matrix B. Then if I do B and then inverse, then I get -1/3, 2/3, and then 0.833, and to see if those are equivalent to what I have here. So -1/3 and 2/3, and this is equivalent to 5/6 and -7/6 there. So I think there's a way to change this to fractions, but I'm not really sure what that is there. So I don't see it on here, but you could go to Desmos or go to your graphing calculator and change these to fractions from decimal form. But, all right, so let's go back here. So that's how to find the inverse of a 2x2. Showed you on the other video, so how to find the inverse of a 2x2. Skip these pages here, and then determinant is a scalar value that can be computed from the It's a scalar value that can be computed from the elements of a square matrix. So here's a square matrix, and we're designating the elements with letters here. So the determinant of A, this is the symbol for determinant. Looks like absolute value, but You have a matrix, it means determinant. So the determinant of A, B, C, D would be A times D, this diagonal minus this diagonal multiplied together. So A times D minus C times B. And so for the examples, I'm just going to go down here. So the purpose of a determinant is to capture in one number the essential features of a matrix. If the determinant is 0, then the matrix does not have an inverse. So here's some examples of if I wanted to find the determinant here of this first one, I would do 5 times 7 minus 7 times negative 6. So this is 35 plus 42, which is 77. This one, 8 times negative 6 minus negative 4 times 5. So negative 48 plus 20 is negative 28. So the first two would have an inverse because the determinant is not 0. This one would be 2 times 9 minus negative 3 times 7. So 18 minus a negative 21. So 18 plus 21 would be 39. And then negative 9 minus a negative 9 is 0. So this particular matrix would not have an inverse because the determinant is 0. And that's a determinant of a 3 by 3. I'll let you do that on the calculator if it comes up. But the check for understanding this week is just working with 2 by 2, the determinant of a 2 by 2 and the inverse of a 2 by 2. All right, so let's go this page and this one. So evaluate the determinant. I'm just going to do the first 4 here. I'm not going to do these because you're not going to be evaluated on this. And then I'll come down here and do the inverse. So the determinant of the first one is 4 minus 2, which is 2. So multiplying these together, negative 6 minus negative 25 is 19. And this one, negative 12 minus negative 20 would be 8. And then negative 10 minus 0 is negative 10. And down here, finding the inverse. Let me make this 100% here. All right, so this says to determine if there is one. So this would be 0 minus 0 equals 0. So inverse does not exist because the determinant is 0. And then negative 10 minus a negative 10 is 0 again. So the inverse does not exist. Determinant equals 0. and find the inverse of these 2x2s here. And then I'll show you how to check it on the calculator again. The 3x3 I'm not going to do, but you just could do it the 3x3 on the calculator. So this one is 1 over 3 minus 9. And then switch these two. And then the opposite of the other two entries. So I get negative 1/6, so get 1/6, 1/6, 9 over 6 would be 3/2, and then negative 3 over negative 6 is 1/2. And this one, 1 over the determinant, 9 minus 12, and then switch these two entries. Doesn't look like anything happened because they're the same. And then the opposite of the other two entries. So this is 1 over negative 3, so negative 1/3 times every entry is 1, negative 1, negative 4/3, and positive 1. This one, 1 over 4 minus 0, and then negative 1, negative 4, opposite of 8, and then opposite of 0 there is not 1. So negative 1/4, 0, 2, and negative 1. And then number 14, 1 over 12 minus 2, and then switch these two into 1. So 4/10 and 1/10, 2/10, and 3/10. I think I did these on the other video, but it's okay. Just more kind of practice with how to do it. On the other video, it was done already. I didn't do them in real time. They were done already. So it should be 1/10 here. And 1/5, 3/10. All right, let's just check one of these. Let's do this one since it has the least amount of fractions in it. So I'll go into the calculator. So new matrix. So 2x2, negative 3, negative 3, and negative 4, negative 3, negative 4, negative 3, and then matrix C, do the inverse, you get 1, negative 1, -4/3 and 1. So let me check my answer here. 1, -1, -4/3 and 1. So it matches with the calculator. I'm going to stop the video here. So this not only gives you an idea how to do an inverse of a 2x2 and a determinant of 2x2, but how to use the calculator to check your answer. And for a 3x3, you would just use the calculators. Very complicated. Even to find a determinant of a 3x3 is a little bit complicated. So we're not going to test you on doing a 3x3 with pencil and paper. You can just use the calculator to find the inverse of a 3x3.